Well, welcome to our talk. I'm glad to have you guys. My name is not Jacob Abbott, but I'll fill in for Jacob Abbott, and I've grown my hair back. But my name is Frank Schwartz now. I lead the CloudOps partner team for the North America and South America region, and I'm here, joined here with Gabriel Costa, who's the partner solutions architect. We're here to dive a little deeper on how to identify and solve security risks on the application layer, and with CloudWatch application signals. And the solution architect, Gabriel, is going to jump in the really deep end, but before we jump into the actual tech and have the demo for you, I want to contextualize it a little bit about how this fits into the overall security and cloud operations context. So just for everybody here in the room, before we start, who's a partner? Everybody else customers? Okay. So our job as partner managers is that we're validating partners in cloud operations. And cloud operations in the AWS definition includes these 5 solution areas of governance, CFM, monitoring and observability, compliance, and ops management, which is essentially ITSM management integration. And you see the crown jewel of cloud operations is observability and monitoring. And it's extremely important for you to know what's up in your environment, for you to actually learn about the security risks and learn about what's going on the infrastructure level, but also on the application level. And because everything fails all the time. You know this quote, this is basically what we go by, and CloudWatch and AWS has traditionally been doing a really, really good job on the infrastructure level, and we've done a lot of investment for our partners, but also for our services to go into the application layer and get more capabilities through CloudWatch application signals to you. Because manually monitoring applications is really hard. So, it's hard to find your dependencies, it's hard to find, especially in modern architectures, it's very difficult to find individual dependencies, and to sift through the alerts that you get from those alerts and the monitoring capabilities is difficult because you get a lot of signals. So we're going to talk a little bit about how to manage the signal overload and prioritize what are the things that you should actually react to versus the things that are kind of okay. So and do that faster, of course. So one of the couple of data points that I want to give here on the common threat exposures. Who has lost some sleep over any of these guys that are here in the bottom? Yes, everybody? Okay, cool. So as you all know, we're at the security conference. This is only going to grow, right? And we're expecting a growth for the end of this year to about 2,900 of common security vulnerabilities per month. And what are the teams or what are the organizations that are more likely to be exposed to this? This is usually the larger companies. They're surprisingly still taking a lot of time to remediate. And the vast majority of those security incidents come from these common vulnerabilities. So it's really important to kind of get a modern solution and get a modern solution to get ahead of it. So with that context, I'm handing it over to you to jump into the technical modern solution.
Thanks, Frank. Can you guys hear me okay? Yeah? Okay, so we need a modern solution, right, to solve all of these challenges that Frank was talking about. And really what we want to do is shorten the time, right, to detect an incident, right, to investigate what is the root cause, and finally to remediate as well, and if possible, automating all of this to have a lower mean time to resolution, right? And that's exactly what we're trying to achieve with Amazon CloudWatch application signals. So this is a feature from CloudWatch, our observability service, that we launched in preview in last re:Invent, and just yesterday we launched this as general available right now in all 28 commercial regions outside of Calgary. So the idea is that we're trying to help you have observability on your application stack. So this application performance monitoring, we're able to do best practices for you in terms of your services, right? So we're able to collect golden metrics in terms of volume, availability, latency, faults, and errors automatically. This is automatically instrumented for you if you're using EKS, we're able to connect automatically and collect metrics, traces, and logs as well. And we build also dashboards, pre-built dashboards for those golden metrics. And you're also able to create SLOs, which is what I'm going to be showing on the demo as well, how you can tie those metrics and SLIs to your business objectives, right? Especially in the context of security, how can you have SLOs for minimal amounts of critical vulnerabilities that we have or exposures, right? And finally, arriving quicker at the root cause. That's one of the objectives of this feature as well in CloudWatch. So we launched with support for Python and Java, generally available since yesterday. And these are the main features for CloudWatch observability on application signals, right? The first one is the SLO dashboard. You're able to create your own SLOs, like I said, but we also have a pre-built dashboard so that you're going to be seeing in the demo. So everything from the golden metrics, from volume, latency, faults, and errors is going to be in there. We automatically discover your services as well without you having to change anything in your code. And you're also able to very quickly go to the root cause of an issue because we correlate the metrics, the traces, and logs for you without you having to do any effort as well. And you're still able to use canary, right, having your synthetics and canaries or real user events all in a single dashboard as well. So in the context of security vulnerabilities, right, how can we tie those things together, right? Having a centralized observability with security vulnerabilities, right? We need something that uses AI so we don't have to do the undifferentiated heavy lifting, right? We need something that can help us with, in terms of automation, right? Discovering those vulnerabilities, surfacing those ups, and relating the metrics and logs that are applicable to those. And we don't want to we want to have a pay-as-you-go and less management as possible. We don't want to have to manage services. So using serverless and event-driven services is always an intention here, and having this integrated experience, right? So what I have here for you guys is this architecture, right? It starts with the source code, right? So whenever you push code for your application into code commit or GitHub or whatever your source code repo is, we can have a CI that's pretty standard. But the thing that we can do is we can automate the scanning of vulnerabilities for your application as a whole using Amazon Code Guru or Amazon Inspector. So Code Guru is an AI-based and machine learning-based static security analysis tool that we have on AWS. So it scans for both operating system vulnerabilities, package dependency vulnerabilities, but also your own code, your own custom code. It scans for hard code, credentials, security leaks, SQL injection, so all sorts of different OWASP-related vulnerabilities we can detect it. If you're using ECR, we have an integration with Inspector where it can actually scan your container images and the dependencies as well as your Lambda functions. So for this demo, I'm going to be showing how we can use Code Guru because it's going to scan all of our repo. And this even works if you have infrastructure as code along with your repo as well. Then we can consume events whenever there's a new vulnerability that Code Guru finds. This is going to surface as an event in Event Bridge. And then we can do some action, right? And the action here that we're doing is two things. One is pushing metrics into CloudWatch so we can have an SLO based on those metrics, right? How many critical vulnerabilities have Code Guru found in our repo? How much time it took for us to resolve those vulnerabilities as well. So all of this can be sent into metrics in CloudWatch, and we can have SLOs on top of that. And finally, when the scanning is completed, there's another event in Event Bridge, where we can use a Lambda to embed ROC with an AI LLM model to actually generate the code changes that are going to fix our vulnerabilities for us and open our pull requests automatically for us. So let's see. If you guys want to take a picture of the architecture, yeah. I'm going to show now a demo of how this all fits together in the context of a demo sample application, right? Yep. Cool. So right now we have our sample application here. Is it playing? Yeah. This is the demo application you guys can find on the repo for CloudWatch application signals. And it's just a pet clinic where homeowners, pet owners can you give a stop? Sorry. What pet owners can actually have services for their pets, right? So this is a small Java application based on Spring, just to exemplify how you can use those in your environment, right? So what we're going to be showing is how do we start this process with the CI/CD, right? So this is our front end. The user is interfacing with the application, right? To start with code pipeline, right? This is the documentation you can see, but it's mainly two steps. The first one is allowing a CloudFormation template to create an IAM role that allows CodeGuru security to get the vulnerabilities from your repo, right? And then step two is just adding that second stage on your pipeline. And you can use not only code pipeline, but you can integrate with Bitbucket, GitLab, and GitHub as well. So this is my code pipeline stage, right? You see there, I have my source repo, and then I create an artifact, and my second stage is just sending that into CodeGuru security. And this is the view that CodeGuru security is going to give it to you when it finds vulnerabilities, right? We can have the number of critical vulnerabilities it finds, the severity level, right, from critical, high, medium, and low, right? And you're going to see each CWE in the title as well, and the details as well. So if we surface into that detail for the first one, it's going to say, what is this vulnerability, right? This one is user-provided inputs are not sanitized, right? So they are logged, and then you can have an attacker checking those logs and using that data, right? Some vulnerabilities, CodeGuru is even going to give you the code change, right? And for others, it's going to give you the suggested remediation, but you're not going to have the code change, and that's where we're going to be using Bedrock and LLMs to actually create the code change for us based on the suggested remediation, like we're seeing here, right? So this one is for closing sockets. This is related to leak, right? Now we're seeing the event bridge, right? And here we're consuming the event for CodeGuru security. Whenever it finalizes a scan, I'm calling a Lambda, and now we're going to be seeing the code in the Lambda, right? So first, we're just setting up some code commit repos, right? And Bedrock details, right? I'm getting the event, the scan from the event, right? The scan name. Then I'm getting all of the data from code security, right? What are the vulnerabilities that it has found? I'm sending that into CloudWatch, and now the main part of the code is actually generating the PR content. You're going to have access to all of this code. We have it in the repo as well. So if you go into this function, what you're seeing here is pretty simple. I'm getting the code from CodeGuru, the vulnerability data, and this is the prompt I'm using. It's just an in-context prompt where I'm saying, you need to write code to send to a PR to remediate common weakness enumeration or CVEs, right? Then I'm adding the finding data from CodeGuru security and the original code from the file where you found the vulnerability, right? And the rest is just Bedrock with an LLM. I'm using Claude 3 and Anthropic here, and it's generating code because it knows how to do code, right? And it knows the remediation that it needs to do, right? And finally, I'm creating a pull request in code commit. And what we have is this. This is all automated, so the Lambda has created a PR for every vulnerability that you saw in CodeGuru. So if you check in here the details, it has added the information, what is the vulnerability in the details, what is the file that is trying to fix, you see here, you see there on each .py, and what is the code changes. So in this case, it was a leak that I'm fixing, I'm closing the socket, right? And then I can surface that into CloudWatch application signals to have a single pane of glass, right? To enable CloudWatch application signals is really simple. In your environment, you go into the console, click in there, and you have a way to enable for EKS, EC2, Kubernetes, and custom services as well, even on-premise applications. So I'm doing for EKS here, I'm enable the add-on, the observability add-on, and then it's just a matter of selecting your service, right, that it automatically discovers for you, and the language. And that's it. It's going to restart your pod, and then it's going to create the metrics for volume, faults, and errors, and the traces, and send the logs as well automatically into CloudWatch. And this is an overview of the dashboard you have available. So you can see here, it has discovered the dependencies for us. We have a standard dashboard for latency, requests, availability. So all of this is created automatically by CloudWatch. And we can see the services as well. It has collected the services. And the cool thing is that you can see every data from latency to faults and errors. So now I'm able to filter which services is giving me more errors, and actually dive deep into that. So if I click into a simple port of the error, I'm able to see the correlated traces, and it goes directly into the logging that was responsible for this error. So if I click here and go into exceptions, I can see exactly what happened. In this case was a page that wasn't found in my web server. And I can create SLOs now for my security vulnerabilities, right? Like I have created here. I don't want to have critical findings on my repo for vulnerabilities, so I'm created an SLO for critical findings need to be lower than 1. And I could do the same for the age as well. So if I want to have an SLO for critical vulnerabilities need to be fixed in 2 days, I can create this SLO, and I can alert and alarm whenever I'm getting closer to that SLO as well, just by consuming that metric that I sent into CloudWatch. So hopefully by now you were able to see how we're able to get all a single view of application performance and availability, but also SLOs that matters to our business in the context of security as well, vulnerability. So I have not only latency and availability, but also the Code Guru security findings and SLOs as well, right? Okay, so in conclusion, this demo you're going to be able to consume on the repo as well, and you can extend it to your own use case. But hopefully what you are able to see is that we're using GenAI capabilities, right? From Code Guru, from an LLM in Bedrock to be able to discover the vulnerabilities, fix the vulnerabilities for us, and generate a PR so a human can review and approve it, and we can fix those faster, right? So all this undifferentiated heavy lifting is being automated. Proactive vulnerability as well, and having a holistic view of our application, CloudWatch application signals, not only in terms of how it's responding for availability, but how we can fix security issues faster, right? These are the, if you want to scan this, so the first one is the application signals documentation. You can find a repo with that demo application that you saw for the pet clinic. And then we have this one is the blog post where we have the repo for this code, where you can use Inspector, and you're going to be able to use this same architecture that you saw here as well as the simple project on GitHub. Okay, I'm going to open, since I still have 2 minutes, I'm going to open for questions.